Our next presentation is a group presentation, Observations on the Security of Operational Technology and Scientific Research. Our presenters are Sean Peisert, visiting from the live stream, as well as Emily Adams, Mark Krenz, and Ryan Kiser. Welcome.
Thanks so much, Jeanette. Thanks so much for all of you for attending the summit, either virtually or in person. I'm sorry that I can't be attending with you in person as well, but I'm glad to be listening in and contributing in the chat. And I'm so glad that everyone is able to meet my trusted CI colleagues. For those of you who don't know me, Sean Peisert, my day job is at the Berkeley Lab, but for the purposes of this meeting, I am Deputy Director and co-PI of Trusted CI. This year, I also am leading the study that we did on operational technology in NSF Science. And I'm here today to tell you a little bit about that with some help from my colleagues and collaborators, Emily, Ryan, and Mark. This is actually only about half the team, and I will certainly acknowledge everybody toward the end, but I'm really glad that all of them will be participating with me, and particularly will add a little bit to the flavor of the in-person presentation for all of you. And so please feel free to direct some of your thoughts and questions to them in person as well, and I will be handing it over to them in a minute. Can we go to slide 2, please? So for the purposes of this study, I'd like to introduce what we mean first by the terminology of scientific operational technology. So everybody has different words for this. So what I'm calling operational technology, or OT, is I think what oftentimes is called, at least in the research community, cyber physical systems. You see research solicitations for doing security of CPSs, things like that. Really, there's a lot of overlap, maybe identical terminology between these things. They're all a little bit fuzzy, but here's what we mean. We're talking about systems that are generally networked, could be wired, could be wireless, could be sneakernet in some cases, connecting to computing systems on one side and either controls or sensors of physical systems of some kind on the other side. So in the NSF major facility context, that includes stuff that's bespoke scientific instrumentation like telescopes. It also might mean commercial off-the-shelf components. It's your heating and cooling. It could be power, propulsion, motors, winches, cranes. I mean, you name it. It doesn't have to be bespoke, but it could. It could be something that you go and buy from big industrial manufacturers. Importantly, I think in the context of NSF major facilities, many of these facilities exist solely for the purpose of operating scientific operational technology. It is that telescope. It is that array of telescopes. It is that sensor network. It is that ship. That's why they exist. That being said, there is often less funding and a lower realization for the need for security for operational technology than there is for information technology domains. But the consequences of these control systems could have physical consequences in the real world, including damage of that equipment, destruction of that equipment, or loss of even human life. So that's the context for this. It's this stuff that connects in some way to the physical world. We tend to pay less attention to it, but it often has even larger consequences than information technology. Slide 3, please. So this is just a flavor of what some of these kinds of things are. Again, think about telescopes in the field. Think about vehicles that may be fully or partially autonomous in some way. It doesn't have to be, but in some fashion. Think about sensor networks. Think about stuff sitting out on mountaintops in the middle of the ocean. Think about ships. Now, just take a look at any one of these ships for a minute and think about, if you were to drill into one of these things, how much operational technology might be on these things. There can be quite a lot. Next slide, please. And just to give you a little flavor of some of these things, think about the GPS, think about the weather sensors, the sounding balloons, wind, web cameras, gas storage, data systems, all of these things. And again, I mean, that some of this is sort of bespoke scientific instrumentation. Some of it is a little bit more commercial kinds of things. Think about, again, heating and cooling is a couple of examples down on the bottom of these things. Even if you think about some of the NSF major facilities, you're like, what about computing? Well, again, it's the halon system in your computer room that does fire suppression. It's the stuff that keeps things from overheating, door controls, environmental monitoring, cranes, stuff that's not even necessarily on ships, but might be shipped to shore. Again, I think most major facilities have stuff that's not necessarily the instrument, but it's all that supporting machinery as well. And that's what we're really here to talk about today. And that's been the study of our focus for the last 9.5 months of this year as well. Next slide, please. So just to talk about our approach a little bit, so for the first half of 2022, we engaged with operators of scientific OT at major facilities to understand the range of practices, understand potential deficiencies that could lead to vulnerabilities and compromises. The second half of 2022, we've been compiling all of this instrumentation and understanding into both a findings document and what we view as a multi-year roadmap of solutions to advance the security of scientific OT. Why multi-year? This isn't the kind of stuff that you can just sort of buy a product and install it in a month. This is the kind of stuff that needs to take place over the course of many months, many years, as organizations evolve, as equipment is refreshed, and so on. And so the intended audience for this study is NSF, the operators of this operational technology in NSF major facilities, and Trusted CI. It's part of our Trusted CI's commitment to help support major facilities in their operation of this instrumentation as well. Next slide, please. And before I turn it over to my colleague, Emily, to dig into this a little bit more, I'd like to offer my sincere thanks on behalf of the whole team to the major facilities that did contribute to this study to date. More to come, the IceCube Neutrino Observatory, NOIR Lab, the US Academic Research Fleet, and the Ocean Observatories Initiative. Thank you to all of them. And with that, I'm going to hand it to Emily, please.
All right. Hi, thank you. So I'm just going to basically touch very briefly on the nature of OT in research and also kind of the quirks that the research community faces with OT and any kind of operational technology they use within their work or our work. So basically, a control loop operational technology, as we think about it in factories or some kind of production, it's a loop or a control loop of a set of devices, set of functions, set of readings that are going to, by design, stay fairly static the whole time. There may be some adjustments if the temperature needs to be adjusted by 0.5 degrees. And, you know, research with innovation and trying to discover new things, it's not going to be a time where we will have to make sure we maintain that static space. So, for example, we have UAVs in the ocean or in buoys in the marine environment. I challenge any of you to describe how the ocean could be a controlled loop. And I think we're all going for drinks later, so I'm happy to talk about that and love to hear your thoughts. As we all know, the research that we do oftentimes is very, very specialized. And as Sean mentioned before, some of these instrumentations are so unique and compiled with different components that you are never going to see anything like this in the rest of the world. IceCube in the Antarctic. Some of those devices or the components of the systems are upwards of 30 years old. You know, you do see that in the operational or industrial control environment, but again, research, the core of the research is to discover new things, adapt your devices to be able to do some additional readings. So there's a couple of quotes here that kind of give you a better sense as to that variability.
Another variable with research that you don't often see in industrial control systems or closed loops is that the output is data. And while there may be research highly invested in getting the same amount of data from the same function and what have you, you're not producing a widget here. But on the other hand, a lot of the data, you want to be able to derive innovation or unique or novel results. So your hope is, and I'm making some conjecture here, and again, happy to explore this a little bit more during question and answer, but the hope is that you're going to be coming up with new data, kind of different than what you would expect from a standard control loop. I mentioned earlier, Sean mentioned earlier, many devices are custom built by researchers. You could have a huge budget for a researcher to bring in devices and then deploy those devices out into the wild, if you will. And the key thing is that they're custom built. Finally, on these points, this one's tough for me, and I would love to hear some audience participation at the end of the talk. But the device functions, for example, Noir Lab, the telescope has shared time with researchers. You rent some time, you look at a piece of the sky where you want to look, and then the function is handed off to another researcher where they move the telescope to where they want it to be and look in that portion of the sky. I challenge folks to identify a similar shared setup in the industrial control systems. So basically what I'm talking about here are the nature of operational technology or cyber-physical systems in research truly is unique. So Sean was, as he stated, this is our goal to be able to help pick that apart and present this to the community in order to help us all wrap our brains around it. Here's a couple points about some additional quirks of OT and research. I touched on some of these already. One thing, I'm just gonna make a couple points because you guys can read the slides as well. The customers are researchers, so I am not somebody walking up in Walmart and getting my Nest device, sticking it on my wall. I actually don't have Nest devices. I assume you stick them on the wall. I don't know. I don't have any IoT in my home. But they're a consistent profile. I'm a user that wants to keep my home at a comfortable temperature. I don't have an example on hand, but there are going to be researchers that want to push the envelope of high temperature or low temperature, and this is not something you can achieve with something you get from Walmart. So the researcher is not a consistent profile. It's another challenge that we face in OT and research. I think I'm going to go ahead and skip down to the bottom. Securing OT is not the same as securing IT. So often, I think it's coming up more in the field of the whole IT-OT convergence. There's a phenomenon where operational technology is starting to become more networked, or because of situations that we've been facing the last couple of years, we have to be able to connect up to the devices that are not typically networked or accessible from the outside. So, why not slap on IT? We got firewalls. Let's go ahead and put, network scanning to make sure everything is safe and secure. Well, anything that we typically, not anything, many things in IT that we consider very good practices in security will bring an OT device down to its knees and or break it, sometimes what we would call bricking it, meaning it will not be able to be used after these IT cross fingers securing capabilities or functions are applied to these OT devices. And I think that's it. And again, I truly sounded like I was joking before, but I really would love to hear later, either through question and answer or over a beverage. If anybody has some rebuttals too, the closed systems are not typically in research, et cetera. So with that, I am going to hand it to Mark, who will discuss some of the findings that we've had. Yes.
Which button do I press? The green one? Okay. Thanks. So earlier this year, we published a findings report that you can find on our website on the results of doing the set of interviews that we did with the different major facilities and projects. So I'm going to go over some of the major, just a high-level overview of the findings. First of all, these major facilities, I should say these major facilities, because it shouldn't be a general statement for major facilities since we only interviewed a few of them. We're aware, they're aware of issues with safety in regards to their operational technology, and they do take it very seriously. They weren't just like hands off installing the technology and then leaving it alone. They also take IT cybersecurity very seriously, kind of as a separate thing, but maybe not necessarily think of OT cybersecurity grouped in with that. Most of the people that we talk to, they have a limited, set of staff that has expertise with operational technology, particularly when you're talking about like remote locations that they have. They might have staff there, they're just part-time or whatever. Some of the host institutions were able to provide some help with the major facilities in regards to IT and OT security, but maybe didn't have the expertise with operational technology that the major facilities were running. And then portions of the major facilities that operate operational technology are often disconnected from IT security. So you might have contractors or people that are just working on the operational technology, and they're not necessarily having regular meetings with the IT security staff or the IT staff in general. So we would see a lot of siloing of those two groups from each other, and in general communication gaps because they're not meeting on a regular basis and communicating with each other. Then the major facility personnel in risk management roles have a limited understanding of the operational technology risk characteristics in comparison to understanding of the IT security risks. So that's mostly from the operational technology people not understanding what the cybersecurity risks are there and not able to communicate them up the chain for things like procurement of devices. And communicating the risks that you'd have with operational technology. And then every major facility that we interviewed indicated that it would be extremely valuable to have a dedicated IT and or operational type cybersecurity specialist. But what we found was mostly they just don't have money in the budget to be able to support that kind of thing. We also found that there wasn't very much documentation around operational technology related security policies. They aren't documenting the fact that these are devices that may connect to the network but don't have any kind of specialized security controls or on them, username and password access and who has access to it and so on. Security properties of operational technology devices wasn't really well understood by major facilities. Security wasn't, an element of operational technology procurement requirements, like for instance, making sure that it has the option for two-factor authentication or something like that. And then, like Emily said, a lot of these devices have been installed for 30 years or expected to last for 30 years as far as their lifetime goes. And then there's limited security features that were available for these operational technology communication protocols, where they could communicate over encrypted channels or have two-factor authentication or integrate with a federated identity system or something like that. And then they oftentimes, major facilities would rely on isolation. They'd have a physical air gap in between their main network and the actual device at hand for securing the operational technologies. But then, of course, that presents the weakness in air gaps, needing to take a USB device to be able to perform an upgrade or maybe set the configuration on that piece of operational technology could potentially introduce malware into the device. Some of the newer operational technology that they've acquired in the past 5 years or so is increasingly has software-defined elements to it, similar to a software-defined network or anything that you have nowadays where, your car runs software, your hearing aid runs software and stuff like that. So even operational technologies that these facilities use is starting to be more software-defined. And then, yeah. So with that, I'm going to pass it on to Ryan.
So since Mark talked a little bit about what it is that we're seeing from operational technology in the major facilities, I get a chance to talk about what we think we might be able to do about it. So operational technology, like I said previously, is central to the mission of a lot of the major facilities. So for example, the academic research fleet exists to operate these research platforms that are chock full of operational technology. The L and I in LIGO stands for laser interferometer. These big things are very big, expensive pieces of operational technology. NRAO, of course, would not be NRAO without radio telescopes. We're relying on operational technology to provide these platforms that we're using for research. And we should be making, and we're not always making that dependency very explicit when we're talking about these facilities, though. So we need to make that dependency very, very clear and explicit in the missions of these facilities. The importance of these assets needs to be very, very clear. And there are major technical and cultural differences between IT and OT. And these two worlds don't always understand each other very well. So this can make it really, really hard for security staff who are really focused on the IT side of the house to get a handle on the risks to OT assets. So we need specialists who can bridge that gap, which also implies that we need some resources to train and pay those specialists so they can actually make that happen. We need to take better advantage of the existing security resources like those offered by the host institutions and other resources, even when it is sometimes painful to do so. We don't have the resources to do what we need, so we need to be taking care of all of the resources that we have available to us. And finally, we can standardize more so that we can stop figuring out the same problems in slightly different ways over and over again with this huge variety of different assets. And you'll notice that these are broken out into short-term and long-term solutions because I understand that there are quite a few of these things that are actually very, very challenging to achieve. Some of these might be idealized dreams of what we would hope to accomplish. On policies and procurement, it's another big component of what we think we can make changes in. We should be including our OT assets in our normal risk assessment and security review processes. These are very important assets. We should be treating them as such. That also means that we're going to need inventories of these assets that are much more comprehensive than we sometimes have right now. So OT networks, the nodes on those networks, their interfaces, who's responsible for them, whatever else, security staff need to be able to get that information quickly to be able to understand these things and understand how to protect them. We're also seeing the security capabilities of these devices improving over time, sometimes rather slowly, but they are improving. So if a new piece of equipment offers security improvements, that should be a part of the discussion when we're talking about procurement or replacement of these assets. And then technical controls. A lot of these assets were not designed with security in mind from the start. And the approach is typically to isolate them completely from any sort of external communications. That's not going to be something that we can maintain over a long period of time, most likely. We're having vendors who are asking for remote access to support them because they don't want to fly engineers halfway around the world to do that support. So we're going to need to connect these devices into other networks, unfortunately. If we're going to be able to do that, we need to understand these assets and how they communicate and be able to communicate about these assets very, very well, which points back to that documentation piece that I was talking about before. very, very important piece of this when it comes to technical documentation is good network diagrams that are very, very complete and very comprehensive. So these should be a part of our review process, is actually checking our documentation and reviewing our documentation and improving it continuously. And we also need a lot more rigor and comprehensivity around how we do network segmentation for these assets. And hopefully, over the long term, we might be able to move towards more of a zero trust model, at least for newer assets that are coming onto these networks. So I think I need to pass it off to Sean here to kick us off for the Q&A in the last 5 minutes that we have.
Thanks, Ryan. Yes, so just to close us out here, looking to the future, this work is what we've been doing this year. Next year, we're really hoping to get a lot more hands-on. We're looking to focus on doing hands-on activities with NSF facilities to try and support building security in from the architectural design and acquisition and implementation from the outset to avoid some of the bolting on kinds of processes that we've seen thus far. I will say, I realize we've focused on NSF major facilities in this topic because they are some of the largest, most expensive, most complicated assets. That being said, it's certainly not our intent to exclude mid-scales and other facilities for which OT applies, nor do we intend to focus simply on just the 4 that we've spoken with this year. This has given us a flavor of what's out there, but our doors are open and we are looking to support all NSF facilities in their secure operation of scientific OT going forward. Next slide, please. I'd just like to acknowledge the whole OT security study team, Andrew Adams from Pittsburgh Supercomputing Center, Emily Adams, who you heard from today from IU, Dan Gunter from the Berkeley Lab, Ryan and Mark, again from Indiana, John Zage from NCSA, and also sincere thanks to Craig Jackson and Susan Sons from Indiana in the planning process, and again to the 4 major facilities that worked with us so far this year as well. Final slide, that is it. Please throw any questions you have at us, and particularly our in-person participants as well.
Hi, thanks for the presentation. I have 2 questions. So one is, Emily, you sort of emphasized the fact that there are, at least in scientific OT, there are very few closed loops, as you would find in industry. So I'm just wondering what's the real sort of applied significance of that difference? So that's question number 1. And then question number 2 is, I was curious how much, if at all, if you had the chance to sort of to look at how this, OT, cybersecurity, OT-IT divide is being handled in other industries, looking there for lessons learned, I guess. Because I have some experience with that in the food and agriculture sector, and I say this, in the spirit of hopefully knowing you're not alone with these issues, helps. But there wasn't, anything that you presented that isn't being struggled with in several other, industries.
Can you go ahead and just briefly summarize the first point you were directing to me? You have a wonderful point.
Oh, sorry. The first question was, you emphasized the fact that there are very few closed loop systems in scientific OT as opposed to in industry. And so I'm just wondering what the practical significance of that is.
Yeah, actually, I appreciate you mentioning that. I think I need to kind of not justify it by any means, but we have an environmental impacts or influences, and then you have the traditional control loop. So I am very happy you brought that up. I gave the ocean as an example of a controlled loop, comparing that to a very, very defined procedural, step 1, step 2, step 3 at a factory. Now, I think what you're getting at is that there still could be controlled loops within the system itself. So I agree, actually I agree with you. We do have controlled loops within systems themselves. It's the environment that they're working within that can be so variable, which is not as typical with industrial control systems and such. I hope I answered your question. Okay, and then the second question, you had 2 parts?
Hi. Test.
Can you hear me? Okay. So for the second question, one thing I'd like to point out was that unfortunately we weren't able to really attend it, but there's actually a industry working group by CISA, I think, that every year they have a cybersecurity convention on operational technology. Unfortunately, this year it happened the same week as that RIW workshop that we went to for NSF, but I did get a chance to go to at least one of the first sessions, and it was fairly detailed in the recommendations, and that's one of the resources that we plan to point out in the findings, in the recommendations report that we'll be publishing. Looks like we're at time, so thank you.